All right. So it felt like after our notes yesterday, especially first hour needed some more guidance on a property that we first introduced in Algebra 1, which is exponent rules plus rewriting bases. And so I wanted to make a short video on that. I would jot some of these things down in your notes. So we're kind of combining what we learned and taking a skill from Algebra 1, which some of us have forgot. So the idea here is, let's say I had 3 to the 1/2 times 3 to the 1/4. And I said, hey, I would like you to rewrite that as 1 base of A. So using our rules that we just talked about, I would have to do add the exponents, 1/2 plus 1/4, to figure out what the exponent of 3 is. If they're common denominators, I can add them together. If they're not, I would have to make them a common denominator. This would be 3 to the 2/4 plus 1/4, or 3 to the 3/4. And so A would just be 3/4. Okay. I'd also then, right next to this, like to do one with division. Okay, so suppose I had 9 to the first power over 9 to the 2/3 power, and I wanted you to write this as 9 to the A power. Okay, similar as to before, but except our rule for division is we subtract the exponents. If there's nothing written in here, it's a 1. So this would be 9 to the 1 minus 2/3. I hope most of us can do 1 minus 2/3 in our heads. If you had 1 take away 2/3, that would be 9 to the 1/3. So the exponent of 9 would be 1/3. Okay. However, then I got to some things where we were doing these rules, but they were not the same base. So, and what I recognized was that this type, maybe we needed some more explanation on. So suppose I had 3 squared, and then times 9 to the 1/4, and I wanted you to write this as a power of 3. Okay, so the issue here is these are not the same bases. So what we're going to want to do is we're going to want to take this 9, and before we start this problem, the higher number, in order to use the shortcut, needs to be able to be written as a base of 3. And so I think we would all agree that 9 is 3 squared. I'm going to take out this 9, and I'm going to replace it with 3 squared in there. But it's still raised to the 4th. Alright. Let's keep going. So we have 3 to the 2nd times 3. The exponent rule is you multiply those exponents together. So 2 times 1/4 would be 2/4, or 1/2. And then I add the exponents together. That would be 3 to the, you could say 2.5, I guess, or 5/2 might be better. Okay. So, if I had something that was maybe division, so how about 27 to the 1/4 over 3, and the whole thing raised to the 4th, and I want you to write that as an exponent of A. Okay, similar question. If I can, I'm going to look at my bigger thing, and I'm going to rewrite it in terms of that base. So hopefully you recognize I could rewrite that 27 as 3 to the third. So I'm going to just take this out and write it as 3 to the third, but that is also raised to the 1/4. The bottom, I have 3 to the first. I'll just write a 1 there because I'm going to need that in a second. And in a minute, I know, it's all going to be raised to the 4th. Okay, let's keep going. I multiply these exponents together. This is 3 to the 3/4 over 3 to the first. I'm still going to be raising that to the 4th. I then subtract my exponents. That's 3/4 minus 1 is negative 1/4. Still raised to the 4th. And then that would be 3 to the negative first. So going back to the original problem, which was to rewrite as an exponent of 3, struggling here with being blurry. All right, so to rewrite that as an exponent of 3, remember, was the original question. My answer was 3 to the negative first. So A would just be equal to negative 1. Okay. All right, so we got same base, different bases where we rewrite one in terms of the other. And then if I was to summarize the last type, it would be, what if you have different bases but they're raised to the same power? Okay, so I'm looking at something like, what if I had like 16 to the 1/2? Oh, here, I'm going to do a different one. What if I had like 20 to the 1/2 times 5 to the 1/2 squared. And so in this case, this is an example of I can use the rule where if these are the same exponents, I can put the bases together and raise them to the same exponents, because sometimes it's going to be easier to figure out. So I'm going to put the 20 and the 5 together. So that would be 20 times 5, or 100 to the 1/2. Okay. And then I raise it to the second. Well, this 1/2 to the second cancels, and this would just be 100. Okay, let's try something else. What if I had 4 to the third times 2 to the third, and then to the 1/6, okay? And I want to rewrite this. I'm going to tell you as a different, or simplify this. So again, we're talking about two different bases, same power. Then the way you want to address this kind is we put them together. 4 times 2 is 8 to the third to the 1/6 power. And I could rewrite that as 8 to the 3/6. The only thing I could really do with that would be 8 to the 1/2. There's no simplifying beyond that. Okay. So the same thing, I could use that same kind of rule with then division. So if I had something of 12 to the 1/2 over 3 to the 1/2, and then raised to the third. Okay, so can I simplify this? I notice these are both 1/2. I'm going to rewrite it as 12 over 3 all to the 1/2, and then to the third. Okay, Let's do the 12 over 3, which is 4, 4 to the 1/2, to the third. The square root of 4 is 2. We'd have 2 to the third, or 8. Okay, let's try one last one. Suppose I had 27 to the 1/2 over 3 to the 1/2 to the 4th. How could I simplify that by using this idea? These are both the 1/2 exponent. I'm going to do 27 divided by 3, which is 9 to the 1/2 to the 4th. 9 to the 1/2 is the square root of 9, which is 3, and we'd have 3 to the 4th. Okay, so I hope that kind of zeroes in a little bit and clears up those two exponent rules. I do have some extra practice that you are to work on for your assignment.